Express bus operate journeys between Southampton and London. Over a period of time, records show that half the bus journeys from Southampton to London take more than 115 minutes, and 5% of the journeys take less than 106 minutes. The operations manager believes that the bus company times from Southampton to London may be modelled by a normal distribution. Use the information above to write down the mean time the operation manager will use in the normal model for the bus journey times from Southampton to London. Well, that's going to be 115 because half of them take more than 115. Use the information above to find the standard deviation the operation manager will use in the normal model for the bus journey times from Southampton to London, giving your answer correct to 2 decimal places. So, if we draw a normal curve, we've got here 115, 106, and this is 0.05. We want the probability of x being less than 1.06 being equal to 0.05. We need to find the z value that goes with that. We can do that from the calculator. If we just go to number 2 menu this time, let's just exit that, okay, and then go to distribution, which is 5, F1 for normal, okay, we want inverse norm, okay, we want variable, but we want to go for the left side, so it's F1, okay, we want 0.05, okay, the standard normal, for the standard normal is 1, the mean is 0, and therefore we're going to get minus 1.645. So that means 5 to the minus 1 is 0.01 is minus 1.645. Okay, before we move on, we'll just get to read the rest of the question. So we'll use that to find the standard deviation. Then it says data is available for 542 bus journeys. A bus journey of time of more than 125 minutes was recorded in 18 of these journeys. Use your answer for A and B to determine whether the model is consistent with this data. Okay, carrying on to find the standard deviation. The thing is, the connection between x and z is this x minus the mean over the standard deviation. Therefore, sigma will be x minus the mean over z. So we'll need to do 106 minus 115 over our value that we just calculated on the calculator. And that will give 5.47, which will give me 5.47. Right, so let x be the random variable, the time for a bus to travel from Southampton to London. So x will be normally distributed with a mean of 115, 5.47 squared. That's the variance. So we want x to be greater than 125. Okay, to do that on the calculator, so we can see where that value came from, because you don't get any tables anymore. So go back to the calculator. Let's exit this, exit that, and then let's just do distribution again. Do normal. Okay, and this time we want NCD. Okay, so sorry, I got the wrong one. Exit. Okay, this is the distribution. Normal F2. That's better. Okay, so we want the lower bound to be 125. So 1, 2, 5. Enter. The upper bound, we just need to put a large number in, so put 1,000 in. Okay, enter. And then the standard deviation is 5.47. Enter. And the mean is 115. Okay, and then you can see we got that value that we just got here before. Okay. Right, so if we multiply that by the number, that probability by the number of number of bus journeys, which is 542, it gives 18.297. So that's very consistent because we were told that 18 buses So it's consistent with the data. Right, the operation manager suspects that the mean time for the bus journey from London to Southampton is less than from Southampton to London. He collects a random sample of 36 bus journey times from London to Southampton. He finds that the mean bus journey time is 112.4 minutes. Use the normal model used in Part C to conduct a hypothesis test to determine whether there is evidence at the 1% level to suggest that the mean bus journey time from London to Southampton is less than the mean bus time from Southampton to London. Okay, so we need to set up the hypothesis that the population mean is equal to 115. There's no difference in the bus journey times. And then that mu is less than 115. The mean bus journey times is less than for London to Southampton. Under 80, x bar will be 115, 5.47 squared over 36, and we'll perform a one-tailed test because you're looking for a definite decrease. Okay, so we will reject 80, and we're testing at 1%, so see where this value came from. It's the way it's better to use p-value because you don't have to calculate this value, but we'll just see where that value came from. So to find that value, if we exit this again, and then go to distribution, normal, and do inverse norm, variable left, exit left, and we'll change this one here to 0.01. Enter, this will put back to 1, enter, and this will put back to 0, enter, we'll get minus. It's a slight mistake because that's 10%, so I need to make the area 0.01, so don't make that mistake. Enter, okay, that's better, minus 2.3263. which is the same value that we got here. Okay, so either we calculate the z value, which is x bar minus the mean over the standard deviation over the square root of n, which is be 112.4 minus 115 over 5.47 over the square root of 36, which will give you minus 2.852. Drawing a diagram, our value is over here because it's much less than that. Okay, so we're going to reject 80. Or if we do the p-value, we're going to calculate where x bar is less than 112.4 using 5.47 over square root of 36 for the standard deviation. So if we go to our calculator, again, okay, so I'm going to exit this. Okay, distribution, normal, we want NCD, okay, so we want the lower bound to be minus a large number, so minus 1,000. Enter. Okay, we want the upper bound to be 112.4. Enter. We want the standard deviation to be 5.47 divided by the square root of 36. So we could put divided by 6, because enter. And we want the mean to be 115. This is to calculate the p-value. Okay, so that gives quite a low p-value, 0.00217, which you can see what we got there. And okay, and as that is less than that, we go to reject 80 again, so our value is going to be here. So make the conclusion, make sure you don't say proves. Okay, we're going to reject 80 and say that there is significant evidence at the 1% level that the bus journey times from London to Southampton are less than the times from Southampton to London. Okay, make sure you use this word significant evidence rather than the word concludes or proves. Should not use those words. Okay, it's been a video to show you how to do a one-tailed hypothesis test. I hope you've understood, and I thank you very much for watching.